recording. Okay. Now recording. Today is February 15th. This is the regularly scheduled meeting of ITSC 2309. The time is 10:05. We're a little slow today. And let's see. I'm going to open a new file. And the file is one of them that I sent to you. Where's mine? Mine is on my desktop. This PC desktop. First thing I want to do is talk a little bit about betweenness in SQL. SQL uses the word idea of between. So SQL says, can I select, for example, well, let me just go through it here. I create a small test table here, test, create table test, and that's very sloppy here. I do not put a primary key. I just put up, oh, golly, it would help if I'd turn that on, wouldn't it? Yeah. I'm a little discombobulated today. I got to start taking a earlier train, so I get here with time to get ready. Okay, the overheads are coming up here. I create a small table. I'm calling it test. If you have the file, then you can see it. And in it, I just have one variable. I call it I. It's an integer, no primary key. And I insert some values into it. Again, I'm sloppy. I don't use the field list. I don't say insert into test I just throw values at it, but I only have one place for them to go, so they get in there okay. And then I want to say select I from test, where I is between 3 and 5. What do I mean between 3 and 5? Let me pull that up a little higher. What could it be? Well, it could be 4. We could be just talking about 4. Lots of times when you talk about betweenness in a computer setting or a list of things from 1 to 10, you might mean include the first one but not the last one. Many times it means that, those of you who have seen C. So one thing, it could be talking about 3 and 4. Less likely, it could be talking about 4 and 5. That's not very likely. Or it could be talking about all of them, 3, 4, 5. And the question is, well, I don't know which one. Well, I do, because SQL behaves the same way. So at least in SQL, it's always going to do the same thing. And by the way, I use a go before and after a create statement. Okay? You'll see people that will use go between everything. They don't really have to. It's a good idea to use it. So here I'm going to, this guy, got 6 rows. And let's see what happens when I say between 3 and 5. Are we taking bets? Notice I got 3, 4, and 5. SQL will behave this way. So if you remember that, well, now you know how betweenness works. Between includes the first one and the last one. So it's an inclusive between. I do not particularly like that. I think that, in my opinion, I think it is better to use this way. For example, select I from test where I is greater than or equal to 3 and I is less than or equal to 5. Now I know I'm going to get those endpoints. But if I don't want the endpoints, I can modify this and I can say greater than or equal to 3 and strictly less than 5, for example, in this one. Or I could just say just this one, just less than and greater than. If I execute this, I'm only going to get the 4. So that's kind of what most people think of for betweenness. If I'm between 2 fences, can I be sitting on the fence? Well, in SQL, that's the way it's going to behave. SQL, if you say between, you are including the endpoints. I personally think it is better to say where I is greater than or equal to maybe the lower bound and less than the upper bound. I think if you said between 5 and 3, it would work the same way. It might go backwards when it printed them out, but you just put an order by in there. Are there any questions on just the straight select from where? Select something, select some set of fields from one single table right now, where some condition or conditions. And we've seen conditions where we joined them with and or. Questions?
If you use the use, I guess, clause up at the top, because I know sometimes you have to say from the database.dbo for the database object and then the table name, does that remove that need to add in all that
yes.
prefixes?
The question is, let me see if I can get this on the speaker. I'm going to try. Select a speaker. All right, testing. Can you still hear me? Okay, say something again.
Yes, sir.
Okay, hear me. Now you're on the room speaker. Go ahead, ask your question one more time, please, for the benefit of the people in the room.
Okay, so the question was, when you're calling the from the table, sometimes in SQL Server, it'll require you to put the database name and then a dot, then DBO for the database object, and then a dot, and then the table name. Okay. So if you use the use, can you take out all that prefix?
The answer is yes. Putting the use at the top, which is kind of why I am insisting on it, stops you from having to say the database name in the select statement. Now you could say it. I could say the from. I could say from scratch underscore DB dot DBO means database owner dot test. This is what we call a fully qualified table name. It's a little bit like, if you're using a folder or something and you change directory to that folder, now you can talk about your files. You can just say from this file.txt. If you are in some other folder and your batch file is trying to talk about it, then you can use either a relative path name or a absolute path name. So this would be an example of using the fully qualified name of it. I've got the database, the owner's name, the schema, and the name of the, and in reality, I could have to specify the server also. So I could have an IP address in here also. Did I answer your question?
Yes, sir.
Okay. Others? All right, so much for the this one. But when we say the use, once we say use, the use is going to remain in effect until we change it, until we say something different. If I open a file and at the beginning of the file it says use scratch DB or some other database, until I execute that, it hasn't happened. Just because I open the file doesn't mean it's happened. I have to highlight it and execute it, because if I just open the file and then jump down into the middle of the file and highlight something, I will not have executed that use scratch DB yet. So I have to execute it. So I would have to highlight it and say execute. Now, once I've done it, I've done it. Now it stays until I say something different. Okay. Next piece of this thing. I have created a couple of tables here. I have created a table called child and a table called parent. I probably, from what we have talked about when we were creating tables, you say, aha, I'll bet there's going to be a foreign key from child to parent. Aha, you are absolutely right. There will be a foreign key coming from child and pointing to parent. Yes, indeed. Here is parents. I guess I should have said children or childs. Create table parents. It has a primary key and a name and a P name. Nice naming the constraints. I didn't get sloppy with this one. Sometimes I do when I'm just trying to do a quick example. Create the table child. Well, it's got a child primary key, a child's name, and the foreign key taking me to the parent table. The constraints are named, as they should be, and so on. And I'm saying that this is poor practice, pointing out I think that will work. Yes, and you will see people do it that way. You'll even see textbooks that will do it that way. I recommend that you not do it that way. When you leave this class, I guess you do it any way you want to. It is possible to name the primary key in the same line and to create the primary key in the same line where you declare it. But the problem with it is that it doesn't have a name. So if I want to go back in later and figure out what went wrong, I don't get to see that name as part of the error message. And that's the most important thing. The other thing I can do is I can disable that constraint if I know its name. It has a name. I just have to go look it up in the data dictionary, and we'll get there later. Okay, let's put some stuff into the parent key. So parent table, parent values 1, 2, and 3, and Bob, Bill, and Betty. Children table, it's 987, Bob Jr., Ted, Sally. Notice that Bob Jr., I don't know why his name's Bob Jr. He's the child of Bill. Notice the 2. Ted is also the child of Bill, and Sally is the daughter of Betty. Bob doesn't have him. I guess I should have made that Bill Jr., huh? I don't know. That's confusing. I'll name him Bill Jr. Okay. So that really had nothing to do with anything. But as you can see, I have one parent that has 2 children, one parent that 1 children, and one parent that doesn't have any children at all. I could have a child with no parent. It's possible to have a child with no parent. There's nothing wrong with that from a database perspective. That foreign key can be null. But I don't have one of those. Now, the question is, will I lose integrity? It depends on what you mean by integrity. I'm trying to say your name. Wana. Integrity would mean if I have a child that has a parent, if I had a parent 4, 1, 2, 3, I don't have a parent number 4. So if I had a 4 in the child table, I would be violating database integrity. By simply having a child with no parent, that is not a violation of integrity unless you say it is in your database. Now that might be something that you need to enforce. If it is, then you would enforce that by putting a not null constraint on the foreign key. So if you came up here where we defined the child and we added a constraint here, check that the PID in the child table is not null, then that would put that integrity constraint, because that's something that you are putting on this table and you have the right to do that, and that might be something that's important. I haven't done that here. Okay, first table join coming up here. select. Let me see. I'm going to tab over. You might want to do this. Okay. Notice some things about this. Select P. Well, let's go to the from line first. From, now this is an old syntax, so we're going to do a little better than this, but let me scroll up. Okay. From what? From parents. Notice that I am renaming the parents table. The main reason I'm renaming the parents table is I don't like to type. I'm a slow typist. I've always believed that good computer scientists are slow typists because it makes us think a little bit more. That may be true, it may not be. Child as C. So I have renamed the tables on the from line. Notice that I have a comma between two tables. So I have two tables in this, select from where. I'm going to select the PID from the parent table, from the P table. Now, notice that I have a PID in both tables. I have a PID in the parents table. I also have a PID in the child table. So if I'm going to talk about down here in this select statement, I want the PID. Notice I have both tables. I'm going to have to specify which table I want that coming from. Questions here, pausing. Juana? Question is, do you have any? Do you have any questions? The hardest thing to get teachers to do is shut up for a minute. I've taught teachers and we just want to say, any questions? Okay, good, fine, let's go. Takes people a minute. Okay, let me go on. Now notice with CID, there's only one table that CID's got to be coming from the child table. No other place. So I don't have to say C.CID. If I did, it wouldn't be wrong. But when I talk about the PID, I want to see the PID from the child table. So I name this one parent PK. It's coming from the parent table. And I name this one parent FK, foreign key, FK, because it's coming from the child table. Okay. Now I wouldn't have to execute use scratch because I was just using it a minute ago, so I think it's still going to be valid, but I'm going to go ahead and create these. Insert. Execute. Okay, good. The old syntax, I'm going to execute this now. And I want to take a look at it because I'm selecting from both tables, and it's going to be a little strange. And maybe copy with headers, and let me go Excel. The nice thing about, you see, are we high enough? How do I shut this thing up? There we go. Okay, nice thing about it is it copies and pastes very well over into Excel. So if you need to format the output of an SQL select statement, Excel is really your tool. Very seldom do you ever give this to human beings to read. Most of the time, the output of an SQL statement is going to another program for further processing. But yeah, if you need to, you drop it into Excel. Now take a look at it. And look what I got. Let's see, what did I do for this? I said, give me Give me these three from parents, comma, child. And this is what I got. Now, how many rows did I have in the parents table? And how many rows did I have in the child table? Well, I'm sitting here holding up 3 fingers. The people online can't see that. I had 3 in each table. How many rows do I have in the final table? 9 rows. So notice how many? I got 3 times 3, 9 rows. If I had 4 fields in one of the tables, either one, then I would have expected to have 3 by 4, 3 times 4 in the output, or 12. And if I had 10 rows in one table and 12 rows in another, I would expect to see 120 rows in the output. And that's true. That's what I would see. Notice that, let's look at the, let's see, the parent primary key and the child primary key right now. Let's not worry about this parent foreign key right now. Let's look at these two. The parent, stop it, parent primary key and the child primary key. Notice that I got, I always try to do with this, 1, 2, 3 with 7, 7, 7. 1, 2, 3, 8, 8, 8. There's no order to them in particular. And 1, 2, 3 with 9, 9, 9. I didn't specify an order. I just got lucky and it came to me in that order, which it usually will. Can't guarantee it. Notice that I got every possible, what do they call that? They call that permutations. Every possible way that I can arrange the parent with the child. Every possible combination of parent-child. 2, 7, 3, 7, 1, 8, 2, 8, 3, 8, 1, 9, 2, 9. And I keep trying to point to the board. 1, 9, 2, 9, 3, 9. Okay. But which ones am I really interested in? Now, the parent foreign key for the child 7, who is the parent's foreign key? Well, it's 3. So the only one I'm really interested in is this one. What about this one too? Am I interested in, so when the child primary key is 8, am I interested in a parent primary key of 1? No, this one belongs to the parent of 2. 8, 8, 2. Yes, it's this one. Let me see if I can. I'll grayscale him. Let's see. So 8, 2, 2. Well, a minute ago I had that. Okay, and then for the last one, 9, 2 also. So this one, this is the one I'm interested in. So what am I really interested in here? I'm only interested in where the parent primary key matches the foreign key. Let's go back over here. Can I get this? And I believe I can right here. I'm not sure. I've added something else to this one. Let me take a look at it. I've added the parent's name for some reason. And I've added the child primary key. I've added the child's name. I don't know why. So I've thrown in a couple more fields. I didn't rename them. Now I chose to rename these guys, the CID and the PID, from the parents as P, child as C. Here is the link. Here is the join field. This is where I am joining. Let me roll that up higher on the screen again. Okay, I am now joining the tables. Before I just said put them all together. Put them together any way you can put them together. So if all I say is parents, comma, child, and whether I rename it or not really doesn't have anything to do with anything, except it saves me some typing down here, because if I didn't rename it, I would have to say parents.pid. Down here, I would have to say child.pid. Same thing for here and here. It just saves me typing is all. Sometimes people won't do it. Some people like to type. I'm not one of those people. So now what will happen when I run this one, I'm only going to get those where I'm going to get 3. I'm only going to get those where, and I'm not going to bother putting this over into, well, I can. I've already got it up. Huh. That's what I said. Huh. There we go. Something went wrong again. Oh, well. I'm going to go back over here. I'm not worried too much about it. Notice that I got the parent primary key, 3. The parent's name is Betty. Betty is the parent of child number 7, Sally. And I know that because Sally's foreign key is 3. Bill is the parent of Bill's primary key is 2, is the parent of child number 8, who happens to be named Ted. I know that because the foreign key takes me to Bill, and so on to Bill Jr. I think yours is going to say Bob Jr., but you can change it. Okay. This is a table join. Table joins virtually always happen on, do they have to? Always? What always? Always is a long time. Table joins in this class will always happen based on a primary key, foreign key relationship. I think. I can't think of any examples we have where they don't. A table join is always following a parent primary key down to the foreign key. Okay. This is the old syntax. Now, this, when I first studied SQL, I had to walk to school 2 miles through the snow. I did. And this was the way we did it. This was a table join. There is a reason from syntax, but it doesn't have anything to do with this one, why we have moved to a different syntax that is slightly different. I want you to look at this. This is called the implicit join syntax. I don't know why. It seems to be pretty explicit to me, because I select from, I just list the tables. Doesn't really matter what order I list them in. And then the where the parent primary key equals the child's foreign key. It's pretty straightforward. There wasn't any reason we had to change it. It works. You'll still see this one in use all over the world. People will still write this way. You know, you're talking to an old-time SQL programmer when they write it like this. It is possible to drop the as. If you drop the as, if you just say parents with no comma, use parents, space P, it will work. You will see people write it that way. We in this class will tend to use the as. If you take my advanced class, I let you start getting a little looser with the syntax, and I start saying, well, okay, you don't have to do that. And here you do, but later you want. You can drop the as and you can just say from parents, space P, comma, child, space C. Same thing with these guys. If you drop the as, it will work just fine. Go ahead and leave the as in there. What else? Okay. The new syntax. Dum, da, dum, dum. Okay, I'm gonna. And then the new syntax. Sometimes I like to stack up my fields. This is one of those things that you can do it this way. If you think it looks better to stack your fields up that way or to write them across, that's just stylistic. That's kind of your call. I don't have a particular way I like it one way or the other. I do not like it when my code under a normal size page, I do not like to have my code scrolling off the side of the page. So this might be one option that you might look at for how you like to see your stuff formatted. I'm going to give you a lot of leeway on it. I want you to put some effort into formatting it. From parents, as P, okay. Here's the word now. Inner join. Inner join, and that's what we're studying right now, is called an inner join. Okay, an inner join, child as C. Okay, so we've got this new word that has come up that we didn't have up there in the old syntax. We didn't say inner join. We just put a comma between them. And so we've taken out that comma and replaced it with the term inner join. It's the same thing. Inner join, child as C. Instead of putting the join fields up here, we put them in the where clause, where the parent PID is equal to the child PID. Down here, we put them in another clause, an on clause. Right? Now, you might have a where clause in here also. I didn't like this one at first. I've kind of warmed up to it. Over the years, it's you know, it's kind of brand new syntax, right? I mean, this stuff came along in like 1992, so it was just yesterday. But anyway, yeah, this was new syntax in 1992. I mean, that's only what, 29 years, 27 years. Okay. This is the same thing. Now, if I were to execute this, execute, I'm going to get the same thing as I did with the other one. They are the same. The old syntax is still just as valid as the new syntax. If you see it, if you happen to run across it, and they write it like this, okay. You don't have to rewrite it. Just understand what's going on. This is the on. And right there's the inner join. But this is the preferred way to do it now. Okay. Why is it preferred? I don't know, because I say so, I guess. Okay, some things I wanted to point out here. Wait a minute, we have lost a parent somewhere along the way. Well, what happened to the parent with PID 1? I forget what that parent's name was. Bob, I think. Where's Bob? I got Betty and Bill, but no Bob. He does not have a child. Okay. Similarly, if I were to put, let's see, how about we insert another? That's Orphan Annie. Get it? You know about Orphan Annie, right? Orphan Annie was a cartoon character, also a play. So Annie, what's the matter here?
The parent ID.
Oh yeah. Oh, duh. What's the matter with me? I have to put a. I have to give them a. I have to give them a child ID. There. There. That's got it. Okay. Now I just go. It's easier just to run it than it is to change anything. Execute. So if we were to, I'll go ahead and use the older syntax. No, I'm going to use this one. The new syntax, excuse me. And if I execute this, notice that I did not see Annie. So I do not see in this kind of a join, this is an inner join. This is the most common kind of a join. In an inner join, I do not see childless parents. I do not see orphans. So a child with a null foreign key is known as an orphan. That's not, there's nothing in database that's not a violation of the table's integrity. Therefore, we don't see them in here. Now, this kind of pointing down the road, we're going to come to another kind of a join where you do see childless parents and where you do see orphans. And we're going to, you know, because it's going to be important to be able to find, hey, how many, do you have any childless parents? How many parents do you have with no children? So I want a list of parents with how many children do they have? So for example, I want to see Bill 2, Betty 1, but I want to see also, I want to see Bob 0. That means I have to be able to find Bob. And I might very well, very definitely want to find childless parents, unmatched records. I might want to find, sometimes, those of you who have taken ITSW 1307, do you remember that? Some of you took it. That was the one with the Shelley Cashman textbook. Anybody remember that? No? Anybody online remember that? I know some of you have taken that. What they do in that textbook, they just start off, the textbook doesn't talk about creating tables, they just start throwing data at Access. Remember, that was Access. ITSW, you probably took it online. I can see everybody's really excited about it. It's not my favorite class to teach because you just start throwing data at the tables. And then you get data in there, and I have parents and children, but I have children because somebody in the class, I've never done this, and somebody in the class didn't put a bad foreign key. In other words, somebody didn't have a parent foreign key of 27. Well, there isn't one. So then later we go in and we try to create that foreign key relationship. And what does Access say? It says something like, or whatever it says. But it won't let you do it. Now, why won't it let us do it? Because we have that would be a violation of data integrity. So if I have two tables and I want to set them up as a parent and a parent-child, in other words, I want to create a foreign key, I can do that. We have been doing it at the table creation time, which is the correct place to do it. But sometimes we'll do it later. And if we do it, I have to go in and find unmatched records. I have to find those invalid parents. And there are ways to do that. This type of a join will not do that. This type of a join will only show me records that participate in the relationship. That's the property of an inner join. Questions? Questions from online people? You guys are part of this too. Got 6 of you out there, I guess. Testing. You guys still there?
Yes, sir.
Groovy. Okay. Just about our break time. Okay. In fact, I can join 2 tables. I'm not limited to joining 2 tables. I can join as many tables as I want to join. For example, I could have grandchildren in here. So I could have my parents, children, and then a table of grandchildren, which would point to the child table, the children of the children. Now, if I wanted to find the parents and the grandchildren, I would have to have all 3 tables in that table joined. I would have to start with the parent table, go through the child table, find all of the matches there, and then match them to their grandchildren, where I have grandchildren matching their parents, matching their grandparents. Okay? It's done pretty much the same way, and we're going to do some examples of that. The table join is our first real getting into SQL. Okay. Let's see, it is 11 minutes till 11 I have, so we're going to go ahead and take a break, and then I'm going to start on multiple joins. We will be using in this class most of the time the new syntax. This syntax is known as the explicit syntax, and unless I actually ask for the old syntax. Oh, one more thing I have. If you choose to write it like this, I am not going to be happy. What did this person do? This person was me.
He dropped the as.
I dropped the as.
In the inner join.
And I dropped the inner from inner join.
When did they pick up that syntax? By the way, I'm curious.
What, from dropping the inner from inner join?
And the as.
And the as. I think it's been there all along. The question was, when did this this quote quote new syntax? So I put down here that yes, SQL will let you do it. Yes, you'll find it in tutorials out there. Yes, you'll even find it in textbooks. Is it wrong? It is in this class. It won't be wrong in the advanced class. So I let people get away with that, and you go to the advanced class, okay, you're advanced students. Yeah, go ahead.
Sounds crazy.
This question sounds crazy. Go ahead.
You can do the inner join, but if you say that those fields are different, are you gonna get the information that doesn't have partner?
I'm sorry. If I say what's different, this name.
In the second PID, different from CPID.
You mean where this is not equal to? No, I'm really going to get a mess if I do that. It's always equal to. We will never have a join. Never what? Never. We will never have a join that uses not equal to. We will never have a join that uses greater than. every time I say never, somebody proves me wrong, but it's always going to be equal to, so we're always going to join on equal. It wouldn't make any sense to go greater. The question was, what Juana was trying to do was get the ones that do not participate in the relationship. And the answer is yes, you would get them, but you would get a lot of other stuff too. Let's say sufficient unto the day is the evil thereof. And we will deal with that when we get to it, because there'll be a way to do that. I'm going to pause the recording now. Okay, recording pausing. The recording back on. I have just turned the recorder back on. After having taken a break, I've gotten my coffee. I am now a happy man. Let's look at this. I was telling you guys, don't worry too much about the red squiggly lines. Why do I have red squiggly lines on everything here? I have not yet executed the use APDB. Now, if you have not yet created the AP, when I execute that, AP, does not exist. Okay, you're going to get to watch me create it here. I haven't created it on this machine. I'm going to create it for you on this machine. The first thing I'm going to do is I'm going to connect. Now, if I connect as, I'm going to collapse this one. This is the one I'm using at this time. It's SW Smith. I'm going to connect to a database engine, right? I'm going to have 2 connections. It's okay to have 2 connections. It's okay to have 5. It's usually confusing if you do. But I'm going to connect with SQL Server authentication. What's this? I'm going to be the, Windows authentication. I'm going to connect with Windows authentication. Notice under Windows authentication, I do not give it a username. What does this say? This says if you're authorized to be on this computer, you're authorized to use SQL Server, meaning that I will be the system administrator under this login. Now I'll have 2 logins open. That's okay, nothing wrong with that. I usually will close one of them because it confuses me, certainly confuses students. Juana, go ahead, please. The question is, can I have them both open at the same time? Yeah. I didn't get that exact. We're going to see 2 of them up here. As soon as I say connect, we're going to see another one pop up right here. Okay, see there's 2 of them. This one is SCCI 122, so this is the one that is the Windows. This one is SW Smith. So
can both be at the Windows authentication instead of SQL Server Windows authentication?
they can be both Windows authentication. Yes, they can both be either or. You can have multiple different users open, connected at the same time. Usually I find that confusing. In the next class, we're going to be working with different users, and sometimes there we will. Here, I'm not going to do much with it. I just need to have be authenticated with Windows. Now, because I'm authenticated under Windows, I can go to databases, right-click, and I say New Database. Are you following me? I'm going to give it the database name as AP_DB. Be careful that you do it like that. The owner is going to be me. You can browse if you want to. Either way, or you can just type in your name. When you say OK, it's going to create this guy. We're not going to worry too much about this stuff down here for now. These are the files, by the way, the file names. Or if I scrolled over, This tells me where the files are, where the file names are, but I don't really care much about that. Don't hit add or you get another file. Just say okay. Right. Ordinarily, I would go, and now if I were creating Scratch, I would go over there and I would make Scratch be my default database, but I don't want to do that now. I don't want APDB to be my default. If I just create something, I want it to go into Scratch. Okay, so my database, my default database is Scratch. Now I am done with this. I'm done. So I have this, I have the Windows login selected. Disconnect. I'm done with him. Okay, now I'm going to go over to see if I can get back to, I thought I had Chrome. I'm going to go to Colin, edu, log in. And I'm going to go to Canvas. I believe we've done this once. I just didn't do it, but it's always a good thing to do it. Both of these are Canvas. This is ours. I'm going to go to the modules. I want to go to Module 2. Module 2, page 5. Create the accounts payable AP database. Download the file, create AP SQL. Let's see. Right click, save link as. Oops. Let's see, download. Okay, I have to click it once and then I click download. I want to make sure I don't save an HTML file. Download. And I think this is in my downloads folder. Okay, that's in downloads. Okay, here he is. Create AP .SQL. I want to go over to my this guy. I want to open. Open, create AP. Wherever you put it, I recommend you put this on your flash drive. Create him, open him. Now let's take a quick look at him. He has use APDB. So he's gonna create that database. He's gonna run through it. He's gonna run through all the tables, delete all the tables. Then he's gonna create the tables and a whole bunch of tables, and then he's gonna load up a whole bunch of data into them. And 700 or 800 rows later, he gets done. And when you say execute, look at that. He ran in about 2 seconds. Yeah, it's fast. And now I can close him. Now I have this. So when I say execute the use APDB, it says successful. Okay. Now I don't know why I still have these red squiggles on that. I don't know, but I do know that that sometimes it just happens that they're going to come in there. Does that bother you? Does that bother you?
No.
It bothers me. So I right click and I go down here and where it says IntelliSense enabled. Right. If there's an error, it's still going to show you an error. It just doesn't put red squiggly lines under it. So if you want to turn them off, you can turn them off. All right. Let's look at what this is. Example, list all vendor name invoice ID pairs. Now, it's perfectly legal. It is perfectly legal for you to, let's see, what is it, tools, under view, say Object Explorer. Where did my Object Explorer go? View. Am I losing? Okay, where did my file go? I always lose those things. File, let's see, I want to dock it. There. It is okay to go to your object. I want to dock this thing. Dock. I want to find my object. Oh, okay, it's over here. It is perfectly legal to go over to your Object Explorer, to go to your databases, to go to your AP_DB. And we're not going to be doing a whole lot of work here, but if you want to find out what's in here, you can go to your tables. And what am I asking you to do? We're trying to find something out about the tables. List all vendor name, invoice ID pairs from the vendors. Vendor name is in invoice in vendors, invoice ID in invoices. It is perfectly legal to go over here, and I want to see, let's see, under my tables. Have I run that? Well, I have run this. Why am I not seeing any tables? Let's see. Sometimes you have to go over here and say refresh, and you have to close this. I know I just finished doing it. Open, file. Create AP, I'm gonna run him again, but I shouldn't have to. Okay. There's my tables showing up finally. And you may have to close it. That doesn't always open. This graphical user interface thing here is really a different program. And just because you have created it in the query doesn't mean it's going to show up immediately in this in your Object Explorer, but it is there now. So I want to go look at the vendors table. So I'm interested in vendors and invoices. I'm going to talk. I may as well talk about database diagrams right now. If I go to database diagram, it says it does not have one or more of the support objects. Say yes, you want to create them. Okay. Now, database diagrams, right click, I say new database diagram. What you've probably seen this before in Access, I expect. It's a handy little tool. What do I want to see? I want to see vendors. There's vendors. I want to see invoices. Now I'm done. Let's see. So notice that I see the relationship there graphically, that vendors is the parent and invoices is the child. It's a little bit scrolling off of our screens there, but I'll go ahead and assume you guys can read it from there. So I see the relationship, the one to many, this guy right here, that's an infinity sign, that means many, I guess. Sometimes you'll see those done with like a crow's foot on it. So this tells us that the vendor ID here matches the vendor ID in the invoices table. And in keeping with good database design, notice that they did not keep necessarily the everything beginning with an I here, but like I do. But I did at least keep the primary key and the foreign key named the same every chance I got. So the vendor ID in the invoices table references the vendor ID in the vendors table. Invoice ID, if there is another child downstream, it would have an invoice ID referencing this. And there are those downstream. So this is what I'm interested in, is this relationship. Okay, I'm done with this. Praise the Lord. Example, list all vendor name, invoice ID pairs. Vendor name is in vendors, invoice ID is in invoices. They're joined on a foreign key. Both tables, vendor ID is the primary key of vendors and a foreign key in invoices. That would be a good one to try it and see if you've got the idea. Here's the solution. Select vendor name, invoice ID. I do not have to notice I said vendor name. I am not selecting the vendor ID. I am selecting the vendor name. Okay, that's an important little point here. I want to see the vendor name, not the vendor ID. Let me go back to this diagram. Notice that in the diagram, I have vendor ID appearing in two tables. If I wanted to see the vendor ID, I would have to qualify the vendor ID. Which one do I want? Do I want the one from vendors or do I want the one from invoices? The reality is that they both have to be the same. It really doesn't matter which one you choose. I usually choose the primary key. But they are the same. This one asks for the vendor name. Okay, so that makes a difference. I can just say vendor name. Vendor name is only in one table, the vendors. Invoice ID is only in one table, the invoices. I don't have to qualify it. I don't have to say v.vendor name. If I did, it wouldn't be wrong. I don't have to. From vendors as V, enter join invoices as I, on. And then I have order by invoice ID. Let's see what we get. I have how many rows? 113 rows. Notice that they are ordered by invoice ID because that's what I said. I have duplicates. Federal Express Corporation, I have lots of those. I think I have lots of some others in here. There's quite a few IBMs. Lots of UPS. So I have duplicates. In other words, those are where the invoice ID, they're parents with many children. So I see the children are showing up there. So basically I'm listing them by children. So I see the parents duplicated. Questions? What if I wanted to change this? What if I wanted to see the vendor ID? Let's change it a little bit. Instead of the vendor name, I want to see the vendor ID, which is going to be a little bit strange because I'm just going to see numbers. So it would make sense to see the vendor name. Well, actually, this makes sense. I see the invoice ID and the associated vendor name. If I changed it and I want to see, instead of the vendor name, I want to see the vendor ID, if I try to execute that, I will get, for my reading pleasure, an error message. Why? Why did I get that error message? And fix it. No, it has nothing. I'm going to get should get the same data.
Well, you got 2 tables with vendor ID in it.
Repeat that, please. 2
You got
tables.
with vendor ID in it.
Both vendor ID appears in both tables. Whenever you see this this message right here that says ambiguous column name, vendor ID, that message right there that I'm highlighting, that message means that that table name, that field name appears in both tables. Now, you might say, that's nuts, Dr. Smith. They have to be equal. They have to be equal. This says the only way they get in there is it's equal. Does it matter which table you take it from? No, it doesn't matter a bit, but you have to tell it one or the other. The computer is not going to make a decision for you. You have to say one way or the other. Even though they're guaranteed to be equal, it doesn't matter. Therefore, when I have a choice, I usually select the table from which it is the primary key. I don't know why, I just do. I have a thing for primary keys. If you had said I.vendor ID, it would work just fine. You've gotten the same output. So now, when I execute it, I get my 113, the same rows, but instead of seeing the vendor ID, I'm seeing the cryptic message questions. Somebody online tell me, we don't have any questions, so I know that you can still hear me.
Yes, sir. No questions.
Okay, groovy. Okay. All right.
So I do have one quick question just to throw it in there.
Go ahead.
Doing the left joins, is it forbidden practice to use a where clause to do joins? So if you want to do like where, one equals the other as opposed to the actual writing out the join?
Using the putting the join field, the join condition in the where clause is the old syntax. I believe I asked you to do the old syntax. Is it forbidden? Absolutely not. But I'm going to most of the time say do the new syntax, except when I say to do the old one. I think it's important to learn the old one. The older syntax has become depreciated in SQL, but it's still going to be around from now on. It's kind of like driving a car with a clutch in it. How many
Okay.
of you have a car with a standard transmission and a clutch? How many of you could drive one if you had to? Okay. How many of you prefer it? I do. Yeah, self-driving cars, and it's, what was I reading the other day, that there's somebody's going to write a country song about how their pickup truck left them for somebody else. That's appropriate. What is this next one? Next one is roughly the same thing as the last one, vendor name. This next one, only thing I'm doing is ordering it differently. So the order by is just different. How do you get this thing to dock? I want to dock it. Dock. Somewhere in here. Properties window.
I found out.
How do you dock it?
Yeah, drag it.
Drag it.
Get off full screen and then drag it to the bar.
Okay. Move him over. I don't want to see this guy anymore. Close him. By the way, you don't have to save your diagrams. If you do a database diagram, it's just all your, when you say don't save it, all you're doing is getting rid of them.
Now make that not full screen.
Make that not full screen.
Yeah.
Here.
Then move it down to the. You might need to click and drag it by the tab.
By the tab.
The tab inside.
Okay.
Yeah, that one.
Well.
Add to his yellow tab.
What's that?
That's working earlier.
What's this? What is this thing down here? Oh, that did it. Okay. Okay, I'm back. The world is right. Control R, get rid of that thing. And now I'll maximize this thing. Let's see, what did we do? This one was ordered by invoice ID. This one is ordered by vendor name. And notice that we see the data slightly differently is all. We see it now sorted by vendor name. You can see it either way. If there are no questions on that one, I'm going to move on. Textbook example, page 134, 135. This is their example. They want to find pairs of names that share a common city. And that's it. We do that a lot in database, believe it or not. If I find it, what will I find if I find select? Okay, if I say select vendor name as name 1, vendor name as name 2. In other words, I select two vendor names, V1 and V2. From vendors as V1, inner join vendors as V2. Okay, this is an interesting example because the table is joined with itself. You can join a table with itself, yes, and that is an important way to, that gives you some important information. I'll show you some, I guess I've scrolled off here, so I'll bring it up higher onto the screen, excuse me. So the table is joined with itself. Notice I had to rename it, so I didn't have a choice about not renaming it. So vendors as V1, inner join vendors as V2, on V1 vendor city is equal to V2 dot vendor city. Is that making sense to anyone? Well, you're strange. It makes sense to you. No, actually, it's not a big deal. I can join it but with itself. Now, notice that it returns a whole bunch of rows, almost 2,000 rows. And if I look at it, so taking these vendor names, execute, notice that U.S. Postal Service is in the same city as the U.S. Postal Service. Well, now that makes sense. National Information Data Center is in the same city as the National Information Data Center. So if I were to find people that live in the same city, you're going to find, well, I live in Denton. I live in the same city as me. So since I'm in table 1 and I'm in table 2, now, you know, you're laughing, but that makes perfect sense. Database does a lot of weird stuff.
You just remove the repeats.
Yeah. Well, usually we don't. Usually I'm interested in, I want to know when someone different. So I want to know the different ones. Okay. So I really don't want to know Stephen lives in the same city as Stephen. Yeah, that makes sense, but it's silly. We can fix this by adding the condition. Okay, I'm going to do 2 of them. This one, the on condition. This first piece of it with that on condition is going to get rid of. Okay, where vendor name 1 from table 1 is less than vendor name number 2. If I said not equal to, first of all, let me do it that way and show you. If I just said not equal to,
You still get the repeats.
Okay.
Having
Right. Right. I get National Information Data Center is in the same city as the Register of Copyrights, and the Register of Copyrights is in the same city as the National, whatever it was. Okay. They're not equal.
They're not equal, but
Right.
but both equals are.
So I can fix that if I go strictly less than, where one of them, the one in the first data table, the left data table, and I am using this term left and right now, and it's going to become important later. We're going to talk about left and right joins. So I want it to be less than. Now when I execute this, I'm going to get only pairs that I didn't put an order by in here, but BFI Industries must be in Fresno. And BFI Industries is the smallest of them, so he's usually going to end up on the left because the rest of these are greater. So I'm going to get the smaller of them. I shouldn't have. Well, I still have it.
And the reason why you do the left is obvious.
I'm still getting duplicates in there. I'm going to have to think about it. It's tricky suppressing those. I live in the same state as Paloma. Therefore, Paloma lives in the same state as Stephen. Therefore, we would appear as 2 different rows. Stephen, Paloma, Paloma, Stephen, because we both live in the same state. That's tricky to suppress. It can be done. Right now, I'm not going to ask you to do it. Okay.
But you don't just go and say, I want the people that live in the same place.
I want the pairs of people who live in the same city. This is the way you do it. You have to join a table with itself. Now, more commonly, that okay, we will have a table like this. I'll have a table of employees. Let me leave you with this one. If employees, okay, so my employees, I've got an EID, employee ID, primary key. I have other stuff, probably a name, probably a extension, you know, anything I'd keep in a table about an employee. But the important thing is that I have the employer's supervisor. Okay, notice that I have the supervisor. Now, the supervisor is a foreign key. The foreign key of supervisor references the EID of the same table. So here we go. Look at this. The foreign key in my table, the supervisor, is a foreign key back into the same table, a self-referencing table. An important idea. Most of our examples that we're going to do from the textbook will be two different tables, but this is one of them that you're going to see from time to time. A table can reference itself. Now, I have a supervisor. In order for me to have a supervisor, in order for an employee to have a supervisor, that supervisor must exist in the table before I put that employee in the table. Does that make sense? I mean, I can't put an employee in the table and have an invalid supervisor. So therefore, if the supervisor is employee number 5, if they supervise employee number 8, then I would have to put 5 in first. Now I can put in number 8 that is supervised by 5. Makes sense? Now, let me ask this question. Here's a cute little one. Will I allow the supervisor, the foreign key, to be null? You say no. Now we have what I call the chicken or the egg problem. Who supervises the supervisor? I mean, is there some supervisor at the very top? The president. Well, who supervises the president? Well, somebody has to, because we said he can't be null. So does he or she supervise him or herself? Well, that would be okay. I don't have a problem with it referencing itself, but how do I put that first record in there? Because it can't be null, and it has to exist before I can put it in. So I can't ever get that first record in there. A couple of things you can do. You can, well, first thing, because we name our constraints, I can go in with a, we haven't done it yet, but there is a command in database called alter table, disable a constraint, turn it off, click. I can turn off the not null. I can put that one record in there where he or she references itself, and now the rest of them follow from that. Turn it back on now. So there are several things I can do there. Let's see, here's alter. I can add the constraint later. Alter table employees, add the constraint. So I put in the EID 1 who supervises him or herself, and now the rest of them follow. So 1A, 1B, 2A are supervised by 1. So as I build them now, but it all goes back to that one employee. that supervises him or herself. We're just about out of time. Okay, now here is, I'll come back to this one. I'll do this one again. We're going to spend probably a better part of another lecture on inner joins. Select EID and the supervisor. So this will give me a list of all the employees and their supervisors. And this one will show employee 1 being supervised by employee 1. Questions? Yes, ma'am.
The same table can have more than one foreign key?
No, you can have as many foreign keys as you want to in a table. A table, I think we have several examples in our database, our AP database, where we have multiple foreign keys in a single table. We will look at another one. The foreign key, a primary key and a foreign key, give us a one-to-many relationship. Will you agree with that? Okay, I haven't made a big deal out of that, but that is the one-to-many relationship. We also have, we're going to build from that a many-to-many relationship. And I have to have a table in between them. That table will have 2 foreign keys going in different directions. And it will relate 2 tables. We call that a bridge table. That's coming later in this course. We're going to practice a little bit more with the idea of this inner join. And then we're going to look at the concept. The next topic that comes up is the idea of the outer join. Now, in the outer join, we're going to see that I can find records that have no match. Okay. I'm going to leave it at that because today we're not talking about that. We'll talk about that later. The inner join. What are the properties of an inner join? An inner join shows only those records that participate in the relationship. Okay, if they don't participate, if I have an employee that, for example, I added this constraint, but if I didn't add this constraint and I had an employee that didn't have any, that didn't have a supervisor, that employee would not appear in the output. If I had an employee that supervised nobody, then they would not appear, they would appear as a supervised employee, but not as the supervisor, which makes sense. So the basic idea behind the inner join is if we have quite a few vendors, we have a number of vendors that have no invoices. In fact, you're going to see we have quite a few vendors in our database that have no invoices at all. We don't see those vendors here in the inner join. And one of the things we're going to do later in the outer join, hey, how many vendors don't have any invoices? I can't answer that with an inner join. Okay. So inner join is the most common. Inner join follows the relationship, but an inner join does not show those records that do not participate in the relationship. Are there questions? Okay, what I'm going to do for those of you who are online, and I think I still have about 6 of you alive out there. What I do at this point is I drop the meeting and I start the process of uploading this to YouTube. It takes a while and I need to drop the meeting and then I will restart the meeting. Okay. I will restart the meeting immediately, and if you have questions or want to stay connected to the class, if you're doing, I will be here until 2 o'clock. meaning that you can stay connected. You can your voice will come over the speaker of the classroom, and take a couple of minutes. So it's going to drop right now, and I will reconnect in the next 2 or 3 minutes, and you'll be able to connect again. Okay, so I'm about to end this meeting, and that will start this recording getting processed. So I'm going to end it now.
Thanks.
And I'll see you on the other side if you come back. Good day.